Okay. Yesterday I went through the first, basically 3 brand new identities with you, and they were all the Pythagorean identities. So sine squared plus cos squared equals 1, and then we divide them all by cos, we divide them all by sine, and we end up with 2 others. Today we're going to do what we call the sum and difference identities. These guys are the ones that you're going to use a lot, and at the start won't make a lot of sense, but it's they're necessary for us to do. Again, all of these identities are given to you on the exam. Okay, they're given to you on the formula sheet, and you need to be able to use them. Now, we used to go through and show you why each one works, but basically all I need you to know is how it works and what it does. So I'm going to start with the first identity that you want to look at. Okay, so again, think of an identity like a physics equation. All right, it's used to make something simpler and make it easy for you. Now, this again has been proven true for every single angle possible. No matter what 2 angles you substitute in for A and B, it will always be true. So the sine of A is equal to. Now, the other thing is, here's the number 1 mistake that gets made. You assume that by putting the sign in front that this says sine times A plus B. That's not what it is. The sine is a function in itself, like add, subtract, multiply, divide. The sine is an actual function button. Okay, it's something that you use to solve. It's not sine times that. That does not equal sine A plus sine B. Okay, what that equals is this: sine A cos B, I believe it's subtract, 1 plus, times sine B cos A. This right here, when I add 2 angles together and I take the sine of the 2 angles, okay, they equal the sine of A times the cos of B plus the sine of B times the cos of A. Do you follow what I'm saying here? Okay, so I'm going to show you the first example. I'm not going through all of these. I'm just going to show you the first one, and then we'll work through questions so that you can see it. But I'm going to show you how this works. Let's take 30 and 60. Okay, A is going to be 30, B is going to be 60. All right, so I've got the sine of 30 plus 60, which is the sine of 90, which is 1. Awesome. Okay, well done. All right. Okay, so everybody's okay so far? Not difficult? Just simply used simple math. Fair enough? Okay. Now, I'm going to plug those same values in here. The sine of 30, cos of 60, plus sine 60, cos 30. Okay? Sine of 30, half. Cos of 60.
3 over 2.
It's a half. Sine of 60. Cos of 30. Okay, so you can see right now, this is why I've been preaching that you need to hammer out that unit circle. This section right here. You're going to do piles and piles of work of this, all right, on the unit circle and knowing these exact values. Okay, what's a half times a half? Quarter. Quarter. Root 3 times root 3 is? 3. 3. Quarters. A quarter and 3 quarters is? 1. Equal. Okay? So what I'm saying to you is this, all right? You need to understand that the sine of A plus B, when I add two angles together and take the sine of it, is equivalent, all right, or the same as sine A cos B plus sine B cos A. Okay? Now, if you look on that page, there's sum and difference identities. The same thing occurs for the difference. So the sine of A subtract B is sine A cos B minus cos A sine B. Okay? You need to have all of those down. Now the second part of this, and again, I'm going through this quickly. Normally I go through this, but we need to get through this as quickly as possible. Here's the second one. These are called double angle identities. All right? Actually, you know what? Before I do that, I'm going to go back to this, and I want to show you the reason for doing this. Okay? The point of this whole exercise, and I said this to you the other day. What if I asked you for the sine of 15 degrees? What's the exact value of the sine of 15 degrees? Right now, it's not on that unit circle, right? We only do 30s, 45s, and 60s, right? But if I asked you the sine of 15 degrees, I want the exact value without a calculator, okay? I'm going to use this identity to show us how to do it, all right? So what if I did this? What if I took two angles that I do know the values for? What two angles can I add or subtract to get
45
50?
subtract 30.
45 subtract 30, perfect. So my question to you is, I want the sine of 15. I want to know what that is. Okay? So I'm going to take the sine of 45 degrees minus 30 degrees. What's the identity say it is? Look at your sheet. What's the sine of A minus B?
Sine
Sine A, so sine 45. Yeah,
A. Cos 30.
cos 30.
Subtract
Subtract.
cos 45.
Okay. Let me do this. Oops. So I just switched them, okay? So now it's sine 30 cos 45. Right? It doesn't matter, but I just like to leave them the same all the way through so I don't make errors. Again, this is on your formula sheet. You can do it. So now, let's put in values. What's the sine of 45?
Root 2 over 2.
Root 2 over 2. Cos 30?
Root 3 over 2.
Sine 30? Cos 45?
Root 2 over 2.
Root 6 over 4 minus root 2 over 4, right? There's the exact value of the sine of 15 degrees. Okay?
You can't subtract the root 2, even,
Well, no. The simplified version of this, Casey, is this. That's a simplified. Okay, remember you've just been listening to what I've been teaching these guys?
Yeah.
Can't subtract apples and oranges, right?
I just thought because they were both over 4.
Oh, yeah. To there.
that
Yeah.
You would be able to get root 4 over 4.
Okay, that's why we're doing this. Okay, so that we can find other special angles using the ones that we already know. Okay, a double angle identity. This is the one that throws complications in. For whatever reason, we can't understand this. So here's the best way I can do this is just say this. Okay, sine 2A. So if I have an angle A and I double it, so the sine of 2A, okay, 2 times the angle. No matter what the angle is, I'm going to multiply it by 2 and I'm going to take the value, the sine value of it. Is also found by taking 2 times the sine of A times the cos of A. All right? Now, I may have been given 2A as a value. Let's say it was 60. Let's say 2A equaled 60. That would mean that A is what? 30. They also, in the old days, used to call this the half angle identity for that very reason. Because essentially 2 sine half of your angle, cos half your angle. Same idea. Okay? So let's show an example of this. Let's use 30 degrees, okay? Two times 30,
60.
sine of 60.
Root 3 over 2.
Okay? 2 times sine of 30,
1
1 half, cos of 30,
half. Root 3 over 2.
right? Okay, called double angle identity. You guys follow that? Okay. Cos has 3 different versions of it. All right. For the cos of 2a, there are 3 ways in which we can find it. Okay. The first is this. The first is that cos squared a subtract sine squared a. All right. Now, yesterday I talked to you about the Pythagorean identity. So let's say I change cos squared. I want to change it to sine squared. How do I change it to sine squared?
1.
1 subtract sine plus 1 subtract sine squared, right? So if I put that in for cos squared right now, I get my second one. It's 1 minus 2 sine squared a. Right? And let's say I had just the cos value, and I didn't have sine, I would change it, right? And I would get 1 minus cos squared, right? Which gives me 2 cos squared a subtract 1. So there are 3 for cos 2a. Follow? Somewhat? Okay. And then the tan of 2a, we don't use this as much, but you do need to know how to do it, is 2 tan a over, what is it, 1 minus
Tan squared.
tan squared a?
Yeah.
Just like that. Okay? So again, you do not need to know how to get these, you just have to be able to apply them. Okay? So let's look at our examples here. Now after yesterday, I know you said you were confused yesterday, so I expect this not to be much easier today. It says write each expression as a single trigonometric function. So I've got cos 32, cos 50, plus sine 32, sine 50. All right? So here's what you do. You look on that sheet of yours and find out which identity you're working with.
Cos A subtract B.
Cos A subtract B. Okay? And what is angle A in this case?
32.
32. And what's angle B?
50.
And you're saying that it's cos A subtract B?
Yeah.
So I've got the cos of 32 minus 50, right? Which is the cos of negative 18 degrees. Does that make sense? So all you do is you look at it, and like I said, this can't be any more like physics in the sense that, remember we started with 5 equations in physics, and I said, okay, pick the equation that has all of the pieces that are given to you. You do the same thing here. Just look off your sheet and find out which identity is similar or exactly the same as that. Okay? What about the next one? 2 tan pi over 6 over 1 minus tan squared pi over 6. Which identity is that?
Tan 2A.
Tan 2a. So I have tan of 2, and what's my a value?
Pi over 6.
Pi over 6. So then that is tan pi over 3. Seems simple, right? Okay? Casey?
Yeah.
It does get a little more complicated, of course. All right, so this is gonna be similar to what we did yesterday. Yesterday you had to simplify expressions, right? So we're gonna simplify expressions, but now we have a major list of identities to choose from. Okay, you have an entire list. I gave you the formula sheet about a week or two ago from the exam, correct? Yeah, you did. Maybe. You need to find that formula sheet. Okay? Because it's going to make it a lot easier if you have that sheet with the identities beside you. The one that I hole punched that goes into the rings in a binder, that one.
Wow.
Oh,
Rings are useless. It's better if it all gets loose.
Color would it be?
I don't know. It's on paper. I can tell you that for free.
This is all paper.
Yeah. Okay, just leave it for now.
Ah,
Otherwise you can write it out. Okay, so here. Look at this right here. This whole section right here is all your trig identities. So, every one of them. Okay? So now, you did miss that day. You've been given it. Before your last test even. Okay, so sine 2x over cos 2x subtract 1. And it wants us to simplify it. Alright, so by simplifying that means change it to so that all the angles are in x and not double angles. Okay, so what's the identity for sine 2x? Flip back to your page at the start and find me what the identity is for sine 2x. How do I change that to a singular angle, not a double angle?
2 sine cosec.
Yeah. So in this one, so I've got 2 sine x. Well, I'm going to do this the same way I always do it. 2 sine x cos x. Okay. What about cos 2x? Subtract 1.
That's just equal to those two.
No, it's not.
Oh, that's squared.
Right. Right. Good pickup. Okay. So what did I say about cos 2x? I even wrote it down for you on the board. Which identity is cos 2x? How do I change it? Do you not have the identities in front of you? I just gave you this one today.
is it cos squared A sine squared A?
Cos squared A subtract sine squared A? Yeah, that's one I could use. Okay, hold on now. Hold on. I'm looking at that subtract 1 right now. So I want the one where the 1 is positive because they can cancel.
Okay.
What is it?
1 subtract 2 sine squared A.
Thank you. So again, I should have done that up here. When you're doing these simplified expressions and you're doing identities, you need to put them in brackets if you make substitutions. So what did you say it was? 1,
Subtract 2 sine squared
2 sine squared x, right, in this case, subtract 1, right? Cos 2x is 1 minus 2 sine squared x. We okay? And again, I cheated here because of knowledge. I want to get rid of that 1, so that's the reason I used that 1. I could have used any of them to get rid of it. All right? So now what am I left with? If I get rid of these brackets here, I got 1 subtract 1, which is 0. So I've got 2 sine x cos x
Negative 2 sine x.
second over negative 2 sine squared x, right?
Yeah.
Correct? Okay. Now To simplify, I have a fraction, right? So how do I simplify any fraction?
Those coming down with it.
No. How do I simplify any fraction?
Reduce.
How do I simplify it?
1/4.
Yeah, how do I simplify it? I reduce, right? So I'm going to reduce. That sine x cancels with one of the sine x's on the bottom. Agreed?
Yeah.
2 cancels with 2. Okay? Anything else I can cancel? No? What am I left with here?
Cotangent.
Yeah. Okay, you went one step further than me. What am I left with?
Cosine over.
Cos x over sine x, negative sine x, right? Which is negative cotan x. Okay? All right. Got that. The only thing I didn't do is not permissible values in here. Actually, I should do that because it's interesting. This can't equal 0, right? So I've got cos 2x can't equal 1. Agreed? Where on the unit circle does cos x equal 1?
Cos x equals 2x.
I'm gonna start with cos theta, let's say, okay? Where on the unit circle does cos theta equal 1? 0 and
180.
no,
Oh, and 360.
what is it? So 0, 360, 720, right? We just keep going around the circle. Fair enough? Okay, so that's where theta, 0 degrees, 360 degrees, 720 degrees, and so on, right? And then go backwards. Agreed? Okay? But like you said, I have 2x here. So therefore, it's where x is equal to 0, 180, 360, and so on, right? Because I have to divide all my angles by 2. Right, you following me? 0, 360 divided by 2, 720 divided. So then how do I write that?
180.
So you're going to?
Yeah.
Okay. So I have that. All right. Questions? It's not easy. Not easy. You're gonna have difficulties, I promise. Look at page 200. Page 200. This is 100% one of the first 11 questions on your exam. Every single exam has this question on it. Okay? All they do is change the angle on you, but it's done the exact same way. It says, determine the exact value for each expression, stating the answer in most simplified form. I want the cos of 7 pi over 12. Do we know where the 12 values are on pi over 12s are on the circle?
Maybe 15,
Yeah.
30, 45, 60.
Yeah. Yeah. Except they're going to be the ones that are all the in-between ones that we don't know on the circle, right?
Yeah.
Okay. So right now I don't know where 7 pi over 12 is. Or I don't know what the value of 7 pi over 12 is. Okay? This is the exact same question I showed you with sine 15. So what do you think I got to do here? What did I do with sine 15? You gave me the two angles. What did I do?
45 subtract 30.
45 subtract 30. So you found two angles that subtracted to give me 15, right? So either I can find two angles that I know off my unit circle that give me 7 pi over 12,
Isn't that just 105?
or add.
270
Yeah.
subtract what would be
Okay, but you gotta use your pies. Okay? But just think about it for a second. What two values add to give you 7 that you know on a unit circle? Like, what are two values?
3 and 1.
3 and 4. Great. I was hoping you'd pick it. Not 2 and 5, because 5 doesn't work. So I got 3 and 4, right? So if I go 3 pi over 12 plus 4 pi over 12, does that give me 7 pi over 12?
Yeah.
Yeah, okay. So let's start with that. 3 pi over 12 plus 4 pi over 12. So far, so good. What does that reduce?
Pi over 4.
And that?
Pi over 3.
Do we know those values on the unit circle? Yeah. Yeah, we do. Okay. So I've got the cos 3 pi over 12 plus 4 pi over 12. What's my identity? So cos, subtract sine.
Yeah.
Does that sound right?
Yeah.
Okay. So you said this is what? Pi over
3. Oh, 4. Sorry.
pi over 4. So I go cos pi over 4, cos pi over 3, right? Subtract sine pi over 4, sine pi over 3. Just like that, all right? We understand what I did there? Okay? So now, do I know the cos of pi over 4? What is it?
Root 2 over 2.
Root 2 over 2. It's a cos of pi over 3.
1/2.
Good. Sine of pi over 4.
Root 2 over 2.
Sine of pi over 3.
Root 3 over 2.
Awesome. See how beneficial it is to know that circle. Okay? So the two things that you're going to want beside you for the next couple days here of this unit, so your unit circle again and those identities. Okay, make sure that you have them beside you, it makes it easier. So now I just simplify. What is this going to equal? Root 2 minus root 6 all over 4. It's pretty similar to the cos of, or the sine of 15 degrees, wasn't it? Right? That is 100% on your exam.
That's the most simplified terms it can be.
That's right. That's it. So how they change it on the exam, they'll ask for a different angle, but still same idea. You're going to need to find two angles on the unit circle. All right. They may ask you for sine and cos. They may say the secant of 7 pi over 12. So if I ask you for the secant of 7 pi over 12, quickly tell me what the answer is. If I ask you for the secant of 7 pi over 12, so that's what?
12 or something.
No,
Oh, sorry. Isn't the 1 underneath that?
not underneath,
One above it.
above it. Right? 1 over cos?
Yeah.
Okay? So I'm looking for 1 over cos 7 pi over 12. What's the answer?
Is that just a fraction?
So what's the answer? Looking at the answer for cos 7 pi over 12, what's the reciprocal of it?
4 over root 2 minus root 6.
Yeah. That's all there is. You just flip it. Okay, so you would solve for the cos all the way through, just like I did, and then I flip the answer to get my secant. Okay? You can guarantee you're going to see that. It's in the first probably 4 questions, if not for sure it's in the first 11 questions, non-calculator section. Either it's in the calculator section, but it shouldn't be. But they put it in anyways. Okay? Alright. I help these guys here. So I got an assignment due. Did you attempt to finish off the first one last night at all?
Nope.
Okay. You got homework this weekend. You need to be done to the end of 6 for Monday on 5.2. I do not assign homework. You guys know that. But I'm telling you, this weekend you need to have to the end of 6. Got it? Okay, you have good.
Does he want that?
Up to 6.
Oh,
No, we need to be finished all of unit 6.
I was like, it's a little expensive. We're gonna learn next week. All on your own.